we will often want to determine whether or not a result is unusual. There are two ways we can do this. We can use the range rule of thumb, or we can use probabilities. So, when we talk about the range rule of thumb, that requires that we know the mean and the standard deviation. So, let's get this, range rule of thumb says that the maximum usual value is equal to the mean plus 2 standard deviations. So we've kind of talked about this before, saying that if you're within 2 standard deviations of the mean, those are our usual values. Okay, that's where 95% of our data lie. The minimum usual value goes the other direction. Now we're 2 standard deviations below the mean. Okay, so how would we use this? Well, if we know the mean for our probability distribution and the standard deviation, then we could determine what values lie within this usual range, from this low to this high. Anything above the maximum usual value, we'd say, well, that's above the maximum usual, that's unusual. Anything below, we would say, with this value, with the minimum usual value, we would say that is unusual. Okay, so that's the range rule of thumb method, and we'll see an example of that in another video. When we talk about probabilities, then we need to look at the rare event rule. So the rare event rule for inferential statistics says that if, under a given assumption, you've made an assumption, the probability of a particular observed event, this happened, you saw this happen, is extremely small, we conclude that the assumption is probably not correct. So you've made an assumption, you observe something that happens, and you calculate that its probability of happening was very, very small. So in other words, did you just see a rare event? Or was this assumption incorrect? Because this assumption is included in your calculations, right? So maybe what you included in your calculations was incorrect. And that's the reason that this actually happened, when this was something that would have occurred if we had understood the assumption better. But under this assumption, we shouldn't have seen happen what we saw happen, is what this is saying. And this is a concept that takes a little while to develop. The criterion most often used that an outcome is unusual is if it has a probability of 5% or less. So we usually consider unusual to be less than or equal to 0.05 or 5%. When we talk about probability distributions and our discrete probability distribution, we might say this. We would say that it is unusually high. We have a value that's unusually high if the probability of x or more, x or higher than x, whatever that is less than or equal to 0.05. So now we're up in that high unusual area range, and then we might say that it is unusually low if the probability of x or fewer is less than or equal to 0.05. So I'm referring this to our discrete probability distribution, where these are counts. So x or more we counted, and the probability of 6 or more, for example, light bulbs in the box that are defective, if the probability of that happening is less than 5%, then we would say, wow, that's unusual. Or the probability of X or fewer, so it's a count. So we're counting, do we have X or do we have fewer? Instead of, if it were continuous, we might use the word less. But since we're counting, we would say fewer. Okay, so with probabilities, this is how we could understand that. And since this is still a concept that we're developing, let's look at an example for rare event rule, and we'll have a range rule of thumb example in another video. Okay, so for my example, while we're still thinking about what that rare event rule says, suppose you assume you have a fair coin. So we say we have an assumption, fair coin. What do we mean by we make that assumption? Well, we mean that the probability of heads is 1/2 and the probability of tails is 1/2. Isn't that what we mean when we say, well, I'm assuming this coin is fair? Well, that's what we're assuming. So we're actually assuming probabilities here that are that become part of the calculation. Okay, which we will get to. We're not calculating that part today, but we're getting an understanding. The probability of heads then is 1/2, and after 1,000 tosses, so here's our example, after 1,000 tosses, here's our observed event. It says that we observe something. You record 421 heads. Okay, here's your assumption, fair coin, probability of heads 1/2. Here's your observed event. You recorded 421 out of 1,000. So here we back to our rare event rule. Okay, under a given assumption that the coin is fair and the probability of heads is 1/2, the probability of a particular observed event. Here's our observed event. Now I have calculated that probability. So the probability that X is less than or equal to 421, okay, X or fewer heads, okay, that calculation comes out to be 0.000000327. Okay, so under a given assumption that the probability of heads is 1/2, the probability of a particular observed event, we observed 421 out of 1,000, is extremely small. Would you agree? That's extremely small. It's much, 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 much less than 0.05. Okay? So we wouldn't have expected that to happen. We assumed it's 1/2. That's part of our calculation. We get 421 out of 1,000, and the chance that that would have happened if our coin was fair is this tiny little number. So do we say, well, a rare event just happened. How weird is that? No, we say, wait a minute. That leads me to believe that my original assumption that I had a fair coin is probably not correct. There's something about this coin that's causing it to maybe prefer tails, because if we had 421 heads, we had 579 tails, right? So it tends to prefer tails. So there seems to be something wrong with that assumption. Okay, so that's the idea behind the rare event rule. And so when we work problems and we use probability to help us decide if we have an unusual event or outcome, then we will usually use this cutoff of 5%, although you'll see other times we may be asked to use a different one. But 0.05 is the standard when in most cases. Okay.